My dear students and friends, in last class we discussed about introduction to stiffness matrix method. In that we discussed about derivation for elemental stiffness matrix, that is in local coordinate system small f is equal to small k into u small. It is in local coordinate system for an element in the truss. Next, you have to convert this local coordinate system into global coordinate system to assemble the elements in the truss. In that, one thing is you have to convert the force in terms of global coordinate system, that is force, by using force transformation matrix T transpose. Similarly, displacement transformation matrix, that is capital U. Here the constant is called as stiffness matrix for the element in global coordinate system. Now, before going to example problem of truss, we have to see what is the procedure to analyze truss using stiffness matrix method. Suppose here if we consider a truss, for example 3 element truss subjected to roller support, hinge support, if the external applied load is say 100 kilonewtons. Now here the analysis means what is the main targets here. Already we discussed this one for truss. The analysis means first you have to determine the reactions here. Okay, that is support reactions. The first target is to determine support reactions. That is, suppose it is say 1, it is second node, it is third node, say it is R1, R2 reactions. There is another terminology for the truss procedure, that is F1 y direction, F2 in y direction. The next thing is you have to determine nodal displacements. Nodal displacements. Because it is stiffness matrix method, it is the relation between displacements and reactions means force F. Okay. The nodal displacements means the degree of freedom at each node. Here generally for each joint in two-dimensional truss, it is having 2 degree of freedom, that is in horizontal x-axis and ux and uy. This each joint have 2 degree of freedom. That means here it may possible to move in x direction, another in y direction, x direction, y direction, x direction, y direction. That have to determine what is the nodal displacement at each node. The third thing is element internal forces. That means here the truss may subject to either compression force or tension force, because the reaction is like this. That means here the internal force should be like this to keep the joint in equilibrium, and here it is in this direction. For element, say it is element 1, element 2, element 3. For element 1 the force should be away from the joint. Okay, that means this element is subjected to away from the joint means always tension. This element 3 is subjected to towards the joint means compression. Now it is also towards the joint means compression. That means it is tension, it is in compression, it is in compression. Now what is this tensile force? That how to determine. Element internal force means how to determine this compression force or tensile force. It is another target. There is another terminology for trusses using stiffness matrix, but not CNT. Now here the procedure, the first step is to divide the truss into elements. Already we divided the truss, given truss, say it is the given truss, into elements, means it is first element, second element, third element. Generally you have to select the nodes or elements in the clockwise, anti-clockwise direction, and it is node 1, node 2, node 3. Okay. It is the first step. You have to identify the elements. The second step is to identify the degree of freedom on each joint, that is nodal displacements. Now here for node 1 the nodal displacements are u1, here it is, in terms of, in the direction of x, u1x, here u1y, similarly here u2x, u2y, for this one u3x, u3y, and here there is applied force, that is 100 kilonewtons. And also here the forces at each node is, here it is f1x, it is f1y, and f2x in this direction, f2y in this direction, f3x in this direction, f3y in upward direction. These are the forces at each node. Okay, the next step, first how to identify this one, but how to determine these values means using stiffness matrix method. But initially we have to identify what are the some, suppose if it is roller support, it is free to move in x direction, that means u1x will exist, but u1y, the vertical displacement for joint 1 is, you can neglect this one, it is not possible to move in vertical direction, that means this value is 0, it will exist. Similarly u2x, it is not free to move in x direction, that means this value is 0, and u2y, it is not free to move in vertical because it is hinge support, it is not free to move in both direction x and y, that means this value is 0. Now at this joint 3, u3x possible, u3y is possible, both are possible, it can possible to move in x direction and y direction. Similarly, what is the vertical force is 100, that means f3y is in vertical direction, but the force is in downward, that means minus 100, and there is no applied horizontal force here. We have to see this one. Next, here you have to identify the forces, but f1x value, because the roller is free to move in this direction, that means this value is 0 because there is no reaction here. But f1y, that means f1y, the reaction is, it is possible, this value is possible. Next, f2x value, because here the reaction, it is also possible, f2y also possible. F2y, F2x are the, suppose it is hinge support, it is F2y, it is F2x. For hinge, both reactions will exist, both are possible. For roller support, only vertical reaction will exist, F1y. F2x value is 0. Okay, it is called as boundary conditions for the you have to use this data is useful at the end of the problem. Okay, next, the third step, how to find the direction cosines. Find direction cosines of the each element, that is cos theta sin, that is L is equal to cos theta and M is equal to sin theta, using some table. The table is here, member or element, next connecting nodes, next what is theta, next L equal to cos theta, M equal to sin theta, next L square, next M square, next Lm, because we required L square, M square, Lm values in global stiffness matrix. Okay, here the first element is 1, which connects 1 and 2 nodes. Okay, and what is the angle theta here? It is very important. Here the angle theta is with respect to the nodes 1 and 2, we consider in this direction, x direction. What is the angle of one element with respect to this line or the positive x-axis? What is the angle of element 1? That is 0. Okay, now what is cos 0? It is 0. Okay, here sin 0 means 1. Next, L square, M square, Lm you have to determine. Similarly for node 2, it is connecting 2 and 3. That means here what is the theta with respect to x-axis? What is this angle? Second element angle, this theta. Now assume it is symmetrical triangle, that means it is 60 degrees. In Truss they will give this data. That means if it is 60 degrees, what is this angle? It is 120 degrees. That means here theta is 120 degrees. Now what is L? Cos 120 degrees, sin 120 degrees. Now L square, M square, Lm. Similarly, now element 3 connecting 1 and 3. Here what is the angle? With respect to positive axis, what is this angle? Element 3 angle is 60 degrees. That is cos 60 degrees, sin 60 degrees, L square, M square, L. This table is used to determine the L square, M square, Lm values, which is used to determine global stiffness matrix. Now the next step is to find the fourth one. Find the stiffness of each element, 1, 2, 3 elements, by developing force displacement relation in global coordinate system. We already did this one, that is, suppose I have to find the stiffness of each element. That means for element 1, suppose for element 1, how to determine stiffness. Say that value is K1. That means here the target is for global, you have to consider capital F is equal to k1 into u. Okay, now we have to determine this k1 value or entire stiffness matrix. Now what is this element 1 connects first node and second node. Now what are the forces here? Here the first element, the forces are F1x, F1y. First element, first node. Second node, F2x, F2y. That means the forces are, here the F value is F1x, F1y. And second node, F2x, F2y is equal to, now the k value, here you have to note down the data, that is AE by L also. Here AE by L. Here in the problem they will give what is the cross section of the A value of the each element and E value. A and E cross section and modulus of rigidity value they will give, and length of the member also they will give. With the data you can calculate AE by L value. Assume for this problem AE by L is constant. That means here you will get AE by L, which is a constant value. And generally what is here, K dash means it is L square LM minus L square minus LM LM M square minus LM minus M square. Next minus L square minus LM L square LM. Next minus LM minus M square LM M square. Now it is for first one. For first data, this value is related to element 1. These values are related to element 1, L1 square, M1 square, L1, M1. Okay, into what is U? U means U1x, U1y, U2x, U2y. The displacement, nodal displacement. U1x, U1y, U2x, U2y. Okay. Now it is global stiffness matrix for element 1. Okay. Now you can find this data, stiffness matrix value, because all are F1x generally in this problem it is 0. It is, this value will exist. Okay. These both values will exist. Okay. It may be a given data or not, but you can find this data using some numerical calculations based on the direction cosine values. It is for element 1. Similarly for element 2, it is connecting with 2 and 3. Okay, here the stiffness matrix is say K2. Now similarly here also you have to form the stiffness matrix, that is F2x, F2y, F3x, F3y is equal to AE by L, which is a constant, L2 square, L2 M2 minus L2 square minus L2 M2 minus L2 M2. Next M2 square minus L2 M2 minus M2 square minus L2 square minus L2 M2 minus L2 square L2 M2 minus L2 M2 minus M2 square L2 M2 M2 square. It is the data from L2 square, M2 square, L2, M2. These values are numerical values. You have to place the values here. And here it is U2x, U2y, U3x, u3y. Similarly, have to determine for element 3. It is connecting 1 and 3, that is say k3. Now k3 means connecting 1 and 3, that means f1x, f1y, f3x, f3y is equal to ae by l, which is constant. Here l3 terms, l2 square m2 and l3 m2 minus l3 square minus l3 m3. Here the matrix value. Okay, and here it is u3x, sorry, u1x, u1y, u3x, u3y. Here it is similarly like this one, element 2 and element 1. Now here it is the second step. Now the third, fifth, it is the fourth step. Now the fifth step is, now you have to assemble all the elements. Here 3 elements in the truss, you have to assemble all 3 elements, that is will get the stiffness for entire matrix, entire truss, that is k1 plus k2 plus k3, or you can write for entire truss f is equal to k into u. You can write this equation also. This k is this one. This procedure is called as assembling of elements, okay, to find total stiffness of the truss. Now how to assemble the elements? Now here for example, you can write this one as total f is equal to k, which is k1 plus k2 plus k3 and u. Okay, here f means f1x, f1y, f2x, f2y, f3x, f3y is equal to, now what is k? Here ae by l. Here it is 6 by 1 matrix. Now what is u? U also u1x, u1y, u2x, u2y, u3x, u3y. It is also 6 by 1 matrix. That means this matrix is in the form of 6 by 6. Now what is this value? Means it is k1 plus k2 plus k3. Now how to find these values? Now here the first term is u1x. It is also u1x, u1y, 6 columns, u2x, u2y, u3x, u3y. Okay, now the first column is related to f1x. Okay, that means here the first element and first 2 lines, first 2 columns and first 2 rows contains first element. Okay, now have to identify the values of first elements in each element, that is element 1, element 2, element 3. What is 1 values? Okay, 1 node values, that is here it contains this data. f1x, f1y means u1x, u1y means this data. Okay, and it does not contains first element, first node, and the Element 3 contains first element, this one, it is L3 M3, next M3 square. That means how to add in element 1, you have to add first 2 rows and 2 columns, and element 3 you have to add first 2 rows and 2 columns. That means here this equation is L1 square plus L3 square is U1x. Similarly, U1y means L1 M1 plus L3 M3. Similarly, this one is L1 M1 plus L3 M3. It is M1 square plus M3 square. Now this term is U1x for global total truss. Similarly, how to identify U2x, U2y terms for F2x, F2y, U3x, U3y terms for F3x, F3y terms. Finally, you will get some matrix here like this, 6 by 6 matrix. After identifying, adding all the stiffness values, okay, you will get 6 by 6 matrix. Now here you will get some equations in terms of F1x is equal to this one into U1x, this one into U1y, next this term into U2x, this term into U2y, this term into U3x, U3y. That means you will get some equations. Totally you will get six equations for forces. Okay. Now the next step is to apply boundary conditions. Initially we identify the boundary conditions. Now we have to apply those boundary conditions to find these nodal displacements and forces. Boundary conditions. Okay. Why these boundary conditions means to solve nodal displacements, unknown nodal displacements. There are known nodal displacements are there, unknown nodal displacements and unknown nodal forces are nodal forces, unknown nodal force. In that unknown nodal force, some forces are support reactions. Unknown nodal forces are element end forces. It is also called as elements end forces, means nodal forces. Okay. That means here the F1x value already previously we identified these boundary conditions. F1x is 0. That means it is 0. F1y value will exist. F2x value will exist. F2y value will exist. There is no horizontal x force here. That means it is also 0. And F3 value is equal to minus 100. Here they have not mentioned any horizontal force. F3x value they have not. That means it is 0. Okay. Next, now what is U1x value? U1x horizontal displacement is possible. That means it will exist and it is 0. And U2x is 0, U2y is 0. That means these and U3x, U3y are possible. That means here that means it is 0, 0, 0, 0, and it is 0. And these are 0. Now identify the formation of equations in which the forces are 0, displacements are 0. That means this total part and this part. Okay, this part is totally zeros. That means here you can form an equations in the form of force is equal to some constants into u. Okay, That means with these equations you will get some equations. Suppose f1y is equal to some, or f1x is equal to, now suppose f1x value is 0, is equal to what you will get, this value will exist, means you will get f1x is equal to 0 is equal to L1 square plus L3 square, and total all are zeros. It is into u1x plus, here you will get some term into u3x, some value here, next plus some value here into u3y. That means here you will get some equation in terms of u1x, u3x, u3y. Okay, and also here by using, that means here by using these four known equations, means next f3x which is 0 and f3y is equal to minus 100. That means by using these three known equations, known values of forces, these three are unknowns. Okay, these three are known values. With this, with the help of these three known values, you have to find the unknown displacements. Okay, that means with the help of f1x equation, f3x equation, f3y equations, you have to solve these are known forces. With the help of known forces equations, okay, how to solve unknown nodal displacements. Those are u1x, u3x, u3y. Okay, after getting these nodal displacements, now these are known data. Now with the help of these nodal displacements, you have to find unknown nodal forces. Now what are the unknown nodal forces? f1y, f2x, f2y. Unknown nodal forces, that is f1y, f2x, f2y. That means first how to, with the help of these three equations, you have to find nodal displacements. After calculating nodal displacements by using these three equations, f1y, f2x, f2y, it will form some equation. Okay, how to calculate these unknowns by using these nodal displacements. Okay, that means finally you will get all forces, that is f1x value we know, that is 0, f1 value here we have to calculate. Okay, f2x, that you have to calculate here, f2y here you have to calculate. Next f3x, that is 0 already, that is known data. f3y, that is known data, minus 100. That means all nodal forces we know. That is the first thing. Here nodal support reactions, that is nodal forces, it is also called as nodal forces. This one we can find, this one. Similarly nodal displacements, that is initially known nodal, unknown nodal displacements. And what are the known nodal displacements here? The known nodal displacements are u1x is, have to calculate here. Next u1y is 0, u2x is 0, u2y is 0. Next u3x you have to calculate here, u3y have to calculate here. That means it is initially known data, it is known data, it is known data, it is known data. Now how to calculate these three. Okay, to get these values, first you have to calculate nodal displacement. These are known data, initially we know these values. First you have to calculate these values, by using these three equations. Next, by using these three conditions on nodal displacement, you have to calculate forces. It is the second target, that is nodal displacements, this one. Now we have to calculate the third objective is element internal forces. Now it is a simple thing. Suppose in this truss, say it is element 1, element 2. Internal force means either compression, here you will get tension. Say this force as it, because it is element 1, say it is F1 dash, it is element internal force. Now the formula for this one is F1 dash is equal to, there is an equation is equal to AE by L into L M minus L minus M into U1x U1y U2x U2y. It is for 6th step, member internal force. The member internal force F1 dash is equal to, either it may be compression or tension, AE by L into L means direction cosine of the element 1, means cos theta, it is sin theta, it is minus cos theta minus sin theta. These are the nodal, already we calculated these values. Okay, now with the help of this equation you can calculate the member internal force. Similarly for second element, that is F2 dash, for third element, that is F3 dash. That means F2 dash is equal to AE by L, it is L1 M1 L. Okay, it is L2 M2 minus L2 minus M2 and U2x U2y. Okay, U3x connecting third element U3y. Similarly F3 dash. These are called as third object, that is member internal forces. It is the total problem. Okay, in next class we will see some example. Okay, with help of this example, that example you can easily understand the concept. Thank you.